Hello, this is question 7 from the 2016 math. So an N fan consists of a row of N points, the tips, in a straight line together with another point, a hub that's not on the line. The N tips are joined to each other and to the hub with line segments. For example, the left-hand picture here shows a 6 fan, right? So 6 dots in a row and then a hub and everything's joined up. For a given N fan, an N span is a subset containing all N plus 1 points. N plus 1, oh yeah, the 6 points plus the hub, and exactly N of the line segments chosen so that all the points are connected together with a unique path between any 2 points. The right-hand picture shows one of the many 6 spans obtained from a 6 fan. In this 6 span, the tips are in groups of 3, 1, and 2, with the top group containing 3 tips. Right, draw all 3 2 spans. So with a 2 span then, so we have to have 2 dots and the hub, and we have to have 2 line segments. Right, so we can go like that, we could go like that, or we could go like that. Okay, that was fine. That's part 1. Part 2, draw all 3 spans. Right, so in a 3 span, just draw out a 3 fan. So a 3 fan looks like that. So we've got 1, 2, 3, 4, 5 line segments. So we've got to remove 2 line segments out of the 5. So at most we're going to get 10, because that's the way of number of ways you can pick 2 out of 5. But are they all going to be valid? No, they're not, because we can't take that one and that one off, because then that one will be on its own. Similarly, we can't take that one and that one off, because that one will be on its own. So we've got at most 8 now. Right, let's draw some out anyway. So let's try and do this in some semblance of order then. So let's draw out a few of these just to get things going. So I'll try 4 on here. See how close we get to 8 then. So that would be one option, wouldn't it? You just go 1, 2, 3, boom, boom, boom. So if we still went to the top and that one, then we'd have to do that. If we went to the top and the bottom one, well, we could do that, or we could do that. So that's 4 options. Then what else might we have? Well, we could do, can we do any others with the top one there? So we've done top. Yeah, of course we could. We could go to the top all the way down, couldn't we? That's the other one we haven't done from the top. Yeah. Then, okay, so if we went to the second one, then we could go up and down. We could go to the second one and up, and then out to that one. So that's 7. Is that all we're going to end up getting? No, because we've got the one going to the bottom, because we must have the reverse. This is what I was looking at. You must have the opposite of whatever happens at the top. We must have the upside down version of it. So yeah, you've got to be able to flip these over. We must be able to get reflection. So these 2 are in a pair. And what else is in a pair? These 2 are in a pair. These 2 are in a pair. And then we've got these 2 outlier ones. But still, that's drawn 8, and we said we can't have more than 8. So that must be all of those. By considering the possible sizes of the top group of tips and how the group is connected to the hub, calculate the number of 4 spans. Right. So we got this 4. So considering the possible sizes of the top group of tips. Right, so let's say this one has got a top group of 1 then, as it's just on its own. So we must have that going up there. So that's something. Then we could have one which has got 2. Then we could have one that's got 3. So that'll be joining down there. And then that. And then the last one will be a group of 4. So they're the possible options. So that's 1, 2, 3, and 4 for our top group size. So, and how the group is connected to the hub. How the group is connected to the hub. Well, that's most obvious, I suppose, on the last one, because we got 4 different ways. 1, 2, 3, 4 different ways that we could connect up. So we got 4 options there. So what have we got for ways of connecting up this then? Here we've got, well, that has to be in there. Well, this is symmetrical with the, oh no, actually it's not. So I was just wondering if it was symmetrical with the one with 1 at the top, but it's not, because we don't have to have 3 at the bottom. They could all be 1s, they could be 2 and a 1, could be a 3. But here we've got 3 ways of connecting up. So we got 3 there. Okay. Right, these ones are far more involved, because, well, this one here with 2, we got 2 ways of connecting to the top, and then we've got a 2 span at the bottom, which has got 3 ways. So we've got 2 ways at the top and 3 ways, so we must have 2 times 3 here, because this is a 2 span. All right, we've got a similar thing here, that we've got a 3 span at the bottom. So yeah, okay, so we've got a 3 span, so we got whatever 3 span is, so we must have 8 there. Is that coming out? So we got 8, we got 6, we got 4, and we got 3. So that's 12, 21. That's what it seems to be saying. Okay. Right, there's definitely some kind of pattern there. I got a feeling they're going to want us to deal with this now, aren't they? For n is greater than or equal to 1, let Zn denote the number of n spans. Right. Give an expression for Zn in terms of Zk, where k is from 1 to less than n. Yeah, so they are asking us to do, it must be whatever this pattern is that's in here, because we've got a 3 span there, a 2 span there. Essentially this is a 1 span, and then we've got 1 way to connect up, 2 ways to connect up, and 3 ways to connect up. And then we've got here, which is just going to be n. That's n. So this one, we got 1 times a 3 span, and then we've got 2 times a 2 span, and then we've got 3 times a 1 span, and then we've got n. So what's going to happen then for, if we're doing this for 5, how are we adding this on? Are we just putting these up? We're going to have, okay, let's go to this. Well, this n would still be the same, but and we're still getting 1 times a 4 span, and we'd have 2 times a 3 span. So yeah, it is going back. These things will be going up 1, and then we'll be dropping in a new span. So, oh my word, right? So what is this meaning then? So Zn is equal to, well, we got n at the end, so we definitely got that. And then we've got, so Zn minus 1, which is this one, we're multiplying by 1. So Zn minus 1. So we want to do this in terms of Zk. Okay. Right, I'll do what's coming naturally and then think about the k bit. So we got Zn minus 1, and then we've got 2 Zn minus 2 plus 3 Zn minus 3 plus onwards. Right, so we're doing that. Right, that's okay then, isn't it? So we want to give an expression for Zn in terms of Zk. For k goes between 1 and up to n. Right, so Yeah, but we've got these rather annoying, well, these are just k's, aren't they? These are our n minus k's. So let's say then that Zn is going to be the sum, that is one wonky sum sign, of k equals 1 to n, no, not n minus 1 of, and then what are we doing on this? So when k is 1, we are getting n, yeah, we want n minus k, don't we, on this? Is that going to work out? I think it is, isn't it? So we want to have z of n minus k multiplied by k. And then we want to add n at the end. So does that come out exactly as I want? So Zn, so if we were doing this then, so Z5, which is what they're asking us to work out, will be it'll be 1 times Z4 plus 2 times Z3 plus 3 times Z2 plus 4 times Z1, and that's gone up to n minus 1, isn't it? So we would have had there, when it's n minus 1, we're going to have, yeah, Z1, that works, plus 5. So Z4 is 21, plus 2 times 8 is 16, plus 3 times, what was this one? 3, so that's 9, plus 4 times, we haven't done the one, well, that'd just be 1, wouldn't it, a 1 span, plus 4, plus 5. So that is 30, 55. Excellent. Oh, that's a relief. Use this relationship to calculate Z6. Right, well, I should be able to squeeze that on here then. So Z6 is going to be Z5 plus 2 Z4s, so that's 42, plus 3 Z3s, 24, plus 4 Z2s, 12, plus 5 Z1s, which is 5, plus 6. So what's that? 97, 121, 133, 144. Right, okay. That was nice. I quite like that one. Again, it was something a bit different, but I think this would have been nigh on impossible to do 3 and 4 without that hint of considering the top group of tips. I mean, we would have been here forever if they hadn't have said to do that. But I think all in all, that was a pretty nice question.